Hi everybody, welcome to my YouTube channel. My objective today is to take a look at a feature of the routers known as the BFD feature. The main capability of the feature over here is to speed up conversions and reconversions times of a routing protocol. If you take a look at a routing protocol like Eigrp, once a particular neighbor goes down, it has to wait for 15 seconds before it starts using an alternate path in its topology table because it takes a hold down time of 15 seconds for Eigrp. So for those 15 seconds, although it has an alternate route, because it's still waiting for the neighbor relationship to go down from the primary route, it's not going to be forwarding on the second or the secondary path. To speed up this, one of the things that they've done on the router itself is they have they have come up with a technology known as the bidirectional forward detection technology, which sets up a neighbor relationship between the two different devices. And if that neighbor relationship goes down, the BFD neighbor relationship goes down, it ties into the routing protocol and it'll bring the routing neighbor relationship down immediately. The way it helps is if the routing neighbor relationship between the two routers that has just gone down is down, it can take the suboptimal path immediately. In case of Eigrp, the hold down time is 15 seconds. We can, using BFD, we have the ability to break that down or bring it down into milliseconds because BFD hello intervals are sent in milliseconds, and you can set your multiplier. For example, I can say that my hello time is 300 milliseconds and my multiplier, or the number of hello intervals that I can miss for me to bring down the neighbor relationship, is, let's say, 3. So within 900 milliseconds, I'll figure out that my neighbor is dead. Now, one of the things that you need to be careful about with this is you need to make sure that you don't do it on a link that is not stable, because if you have a link flap, it can cause problems in your network. All right. So with that in mind, we'll take a look at Eigrp. We'll do the same thing with Ospf, in which the actual effect is even more pronounced because the hold down time in Ospf, called the dead time, is 40 seconds. All right. So I can detect a link failure within in a sub-second manner if I want to. You can change it. It's up to you what you set the Bfd interval at. We'll show you how to do it for Eigrp, Ospf. We'll do it for BGP as well, and then ISIS as well. BGP is 180 seconds. The hold down time for ISIS, it is 30 seconds. So again, all of these routing protocols, I can bring down the detection of a neighbor being down into a sub-second manner using this feature called BFD. So the first thing I want to do is set up a neighbor relationship between R1 and R2. Take a look at it. Once it's done, I'm going to bring it down without BFD and show you how long it took before it actually detects the link failure. And then I'm going to do the same thing with BFD turned on. So what I'm going to do over here is I'm going to set up a network. I'm going to set up a loopback over here, 1000, connect R1 to R2 over 192.1.12.0, and this would be the 2 network over here. So that's a simple Eigrp setup that I'm going to do to show you or demonstrate BFD to you for Eigrp. So let's take a look at how to do it. I have my routers up, but don't go by the name. I'm going to change the name right now. The host name over here is R1. Normal stuff. Loopback, I'll say 111. My Ethernet. Eigrp 100, turn off auto summarization, advertise 1. On R2, alright, so that's my Eigrp setup. Now, what I want to show you guys over here is I'm going to bring the interface down between R1 and R2. I've done that already over here. Although I brought the neighbor relationship down over there, the neighbor relationship over here is still up. And it takes about 15 seconds for it to go down because the hold down time by default is 15 seconds. So right now, within 15 seconds, it'll detect the neighbor is down, although it has been 15 seconds before I detect that the neighbor is down. So if I had an alternate path right now, I would have waited for 15 seconds before I would forward on the alternate path. So let's bring it back up, bring it back to normal, and take a look at how to do it based on BFD. All right, my neighbor relationship is up. So how do I set up BFD? The first thing that I do is I go onto the interface that is facing my neighbor, and I set my Bfd interval. All right, Bfd interval for the transmission, I'll say is 300 milliseconds. This is in milliseconds, by the way. All right, the smallest number of milliseconds you can keep is 50, which is too small of an interval, so I'll keep it at 300 milliseconds. So I can keep my detection time within 1 second. This is my send. How often do I send? How often do I receive? Let's say it's also 300 milliseconds, so I'm expecting a hello from the other side coming in 300 milliseconds. Multiplier, how many of those can I miss for me to call the neighbor dead? Which is, I'm going to set it to 3. The minimum you can set it to is 2, just to show you that. Oh, actually, minimum is 3. 2 is not acceptable. All right, clear? Although I've set this up, once I've set this neighbor relation, once this thing will come up, I also need to link it up to my routing protocol. So I'm going to do router Eigrp 100, and I'm going to specify in Eigrp, I have the ability to specify the interface that I want to link up, which is E0/0. And this luxury you don't have with the other routing protocol. The other routing protocols, you would need to specify it based on all interfaces. Either you turn it on or you don't turn it on. So I've done that. I've linked up BFD to my Eigrp routing protocol. So I'll do the same thing over here. Go onto the interface, Bfd interval 300, minimum receive is also 300, and the multiplier I'll keep it at 3, and then link it up to under Eigrp. Bfd interface E0/0. As soon as I do that, I also will get rid of the Eigrp 1000 that I created by accident. If I want to check it now, I can check my Eigrp neighbor relationship is up. You can also check your BFD neighbors. Notice that I have a neighbor which is up with the other side. If you want to check details over here as well, you can also check that it's linked up to the protocol Eigrp over here. And the round trip times and all that type of stuff is listed over here, the intervals and all that. Now let me show you the same thing that we did prior to BFD. I'll bring the interface down, and you'll notice that as soon as I bring it down, because it's sub-second, I will detect that on the other router and bring the neighbor relationship for Eigrp down immediately as well. So I shut the interface over here, and immediately Eigrp comes down because BFD peer is down. So if I did have an alternate path in my topology table, that would be inserted in my routing table immediately, and I would go forwarding within a second rather than waiting for 15 seconds to do that. All right, hopefully that is clear with you guys. So if I had to set this up, or the commands for Eigrp, first of all, for BFD, general BFD commands, under the interface, Bfd interval, set the time, min, receive, and the multiplier 3, and then under Eigrp I did Bfd and then specify the interface that needs to be linked up. And that's about it. Pretty simple to do, and it's very effective in terms of conversions and reconversions. Now we'll do the same thing with my second setup, which is Ospf between R2, R3, and R4. I'm going to set up Ospf over here and do the same thing between on the Ospf links. Let's do that on R2 now. R2, the other interface that I have, E01, 23.2. Alright, router Ospf1, router ID, wrong place. I was on R1, so I need to do this on R2. 23.2, which is the link between 2 and 3. Router OSPF 1, router ID, let's say 2222, network 23.0, area 0. We'll also advertise the 2 over here. I'll go to router 3. .3, that's the link between 3 and 4, and I'll create my loopback over here. Run OSPF, router ID 3333, network 23, and 34, and the 3 network. Show IP route OSPF, I should have the 2 route, and bring 4 up as well. So let's check, let it come up. Just the wait time for the neighbor relationship. This one should have one up, the other one's coming up. This is the router in the middle. If you want to take a look at the topology, this is the router I'm on right now. Again, I'm going to do BFD over here on both the interfaces. Now you'll notice when I do it for OSPF, I don't have an option of doing it per interface. It will be done for all the interfaces that are under OSPF, so it's not per interface. So router 2, show IP route OSPF, I should have 3 and 4 over here. I want to do BFD E01, BFD interval 300 min 300 multiply 3, route OSPF 1, BFD. I'll show you that the only option that you have over here is all interfaces. So anything that's enabled for OSPF, I'm enabling BFD on it. So not per interface, you don't have that choice. Over here, the same thing under the interfaces, BFD interval 300 min 300 multiply 3, and I'll do the same thing with the other interface, and OSPF BFD all interfaces. So now if I do show BFD neighbor, one of them will be up, which is towards 2, 4 is down. So if I do 4 right now, route OSPF 1 BFD all interfaces, now both my neighbors for BFD should be up. Now if I bring my link down, any one of the links down, let's say E0/0, I will immediately know that my OSPF neighbor is down. What's the default timer for OSPF? If I did not have BFD down, it would have taken 40 seconds for it to bring it up. Let's also try that because I didn't give you a chance to see it before. So what I'll do is I'll take BFD off one of the interfaces. So let's do it on towards between 2 and 3. I'll go to interface E0/0. I'll take that interval off, and now if you do BFD all interfaces under under OSPF, it'll only do it on the interfaces you have BFD enabled. So it's not like just because it's there, all interfaces doesn't mean that it needs to be done on all interfaces. All interfaces that have been enabled for BFD is what it means. Take it off. Alright, so show BFD neighbor, it should only have one. E01 is also down, so I think I had kept it down. Admin down. Is it over here? No shut. One second. Alright, so let me see why the neighbor is down. Show IP interface brief, both are up. That's the Eigrp one that I'm just checking. Show Bfd neighbor. Yeah, why is it down? Oh, I must have taken it out on this one. Okay, this one is up. 23 is down. So on 23, what I'll do is take off Bfd. No Bfd interval 300, min 300. Let me check now. Alright, there's nothing on this guy now. And shouldn't be anything over here. So if I go to router 2 and do show Bfd neighbor, I should only have one neighbor. Now, is my Ospf up? I'm up with 3, right? Now, if I bring this guy down, I don't have Bfd on. Take a look of how long it'll take before this neighbor comes down. The default dead time is 40 seconds. So it's going to wait for about 40 seconds before it detects that the neighbor is down. Although the neighbor is down already, it's been down for a while now. So that's where in Ospf, because the dead time is a longer period, although you can change it into seconds. You cannot do it to a sub-second number that you can do with Bfd. It's a fabulous tool for that type of stuff. So eventually it went down, right? So bring it up and do the same thing with Bfd on in Ospf. So again, I will bring it up, let the Ospf neighbor relationship come back up. Okay, the Ospf neighbor relationship is up. Alright, now my Bfd, I don't have it towards him, I only have it over there. So E0/0, Bfd, interval 300, min 300, multiplier 3, and I will do the same thing on R2. Show Bfd neighbor. There you go, I'm up now. Now let's take a look. If I bring the interface down over here, I won't have to wait for 40 seconds for it to know that it's down. It's down immediately. Alright, clear? So that is Bfd with Ospf. Again, huge difference. We'll do ISIS and then we'll come into BGP at the end. So ISIS is between 5 and 6, E01 of R5, E00 of R6. We'll set up ISIS in the same area, single area. We'll do IS type 1. So 5 and 6. .56.5. Create a loopback. Run ISIS. 49, area 0. Let's say the system ID is 5. And it's IS. And IS type level 1. Done that. interface loopback 0, IP router ISIS, interface E0/1, IP router ISIS. Let's go to router 6. Same area. IS type level 1. Interface loopback 0, IP router ISIS. Interface E0/0, IP router ISIS. Do show ISIS neighbor. It's up, and the hold down time on ISIS by default is 30 seconds. So it's going to be hovering between 21 and 29 or 21 and 30 if you hit it on the head. So (25, 24), it's getting the hellos, and eventually it gets another hello. So 29 is your timer. So if I bring it down over here, shut, it's still up. Right? Took some time. It's not as slow as Eigrp or Ospf, but it still took some time for it to come down. So now over here, how do I do BFD? Same way. Set it up on the interface. Link it up under ISIS. Again, all interfaces. That's the only way you can do it. All ISIS interfaces that you have BFD enabled on. Same thing, E01 over here. Enable the interval and the multiplier. Router ISIS, BFD, all interfaces. Done. Show BFD neighbor. There you go. Now let's bring the neighbor down. Shut, and immediately you should see it doesn't give you that message, but it's gone. It's almost immediate. Alright, that's ISIS for you. If I had to put this over here in your notes type of thing, so this is for BFD is the same for all the different protocols. I would just need to change this part for the different protocols. For Ospf, as you guys saw, that's how you do it. Also for ISIS, it's the same way. Alright, BGP is a little different. So the next thing I want to show you guys is BGP between R4 and R5 to inject the routes, let's say from the ISIS domain into the Ospf domain. We'll do redistribution of Ospf into BGP and ISIS into BGP over here. Let's do that on 4 and 5. So let's go to 4. Let's change the name first. E01 45.4. For BGP, again the same thing. I'll do the interval. Alright, under the interface, E01, router BGP 1000, let's say. We'll say neighbor 45.5, remote AS is, let's say 2000. Redistribute Ospf1. So should see these routes come in eventually over here. Meantime, we'll set this neighbor relationship up. Bfd interval. Done. Router BGP 2000 45.4, remote AS is 1000, redistribute ISIs. And the neighbor relationship come up for BGP. There you go. Now over here, if you take a look, the hold down time is 3 minutes, 180 seconds. Let's check if my routes are there. There you go. I got 2, 3, 4 from the other side and some local routes as well over here. Alright, so once I get the routes and I want to do BFD, it's done per neighbor. So on R4, I'll say neighbor 192.1.45.5 fallback BFD. That's how you fall over BFD. And on R5, you would do the same thing. Neighbor is 192.45.4 fall over BFD. Show BFD neighbor details. Registered protocol is BGP. Clear? So again, if I bring the neighbor relationship down, the BGP E00 shut down, BGP adjacency down because BFD is down. Clear? You guys okay with that? That is BGP. I hope you guys enjoy the video. I hope it is useful. You should implement this in your topology to have better convergence in your networks. Keep watching the channel for new videos over here.